Good day, everyone. I'm Hisyam. I'm representing UCSI University Kuala Lumpur campus, and I'm going to present my papers entitled Assessing the Critical Factors of Safety for Gabion Walls at Various Separations and Slope Ratios using Morgenstern-Price method. Okay, I'm going to start with the introduction regarding about why we conduct this research, why we conduct this study. Okay, basically we know that there are numbers of cases happen in Malaysia specifically where we know that slope failures have threatened the infrastructure, including the transportation lineage. Okay, basically short failures involving a mechanisms such as topple, rock slide, free debris flow that could threat the infrastructure, transportation corridors, and also the human safety. Okay, one of the reasons why these things happen, maybe later I will explain in the next slides, why could these slope failures happen. Okay, so among all these slope remedial works, Gabion walls are widely used for slope stabilization. Why I'm focusing on this gabion walls? Okay, we know that gabion walls provide flexibility in terms of the permeability and low construction cost. Okay, these gabion walls normally custom involved with a wire mesh and also wire cage that we fill up with the rocks, and it can be useful to stabilize the slope and also can be effectively prevent the erosion. Uh, the permeability of the gabion wall itself can reduce the amount of the hydrostatic pressure that enhance the integrity of the structure. Okay, we go a little bit further about what are those factors that affect the slope stability. So basically, the slope stability happen that can be affected due to natural factors. Okay, number one, soil types. Each soil types have can produce what we say the strength. Different soil, different strength. Different types of the soil composition itself can produce a different strength. So thus, by having understand the composition of the soil component itself, whether what is the percentage of the sand, silt, clay, and the gravel, and so on, so we can know the strength and the stability of the slope. That's number one. Number two, the component of the slope itself might be content of rocks. If the rock is having a high fracture, potentially can reduce the strength of the slope. If the rock having high quality, that high strength could also strengthen the slope itself. So that's number two. So for the slope angle itself, by having a slope angle can also stable the position of the slope. The stability itself depends on the angle. Uh, Public Work Department have list numbers of the guidelines, the slope angle in order to maintain to make sure that the slope is potentially maintained and stable based on the ratio vertical and horizontal. So the Public Work Department, known as JKR, also have listed the guideline, what is the condition, the slope angle, and what height that can make sure that when we come up with the slope remedial works, it can be accepted and potentially stable in terms of the ratio of vertical and horizontal. Number two, in the main cause, what makes the factors affecting the slope stability is human factors. We know that with the current involvement, with the current development, there are so many excavation works have been done. Deforestation happened, having a high infrastructure loading and also poor drainage. That could be affect the slope stability. And number four, one of the main factors that affected the slope stability is the climate change that can be impact more intense and frequent. For example, during the monsoon season, where we receive the high intensity of the rainfall. So in this study, there are four objectives that I'm going to list out here. Number one, of course, when we conduct the study about the slope stability, what we look into is to evaluate the factor of safety where we do the analysis based on the Gabion walls. So number two is to assess the effect of material type. Okay, basically in this study, we are using three to four types of material, a field material for the Gabion wall to look whether uh, the factor of safety is it high or low. And number three, to assess the saturation condition, also based on the wall geometry. And of course, in this objective, we are using the Morgenstern-Price limit equilibrium method for to assess the stability of the slope. Okay, why I'm using this Morgenstern-Price? Basically, it is one of the most common approach for the design. Instead of the Bishop, Bishop is also one of the methods that can be used to assess the stability of the slope. However, Morgenstern-Price also one of the most commonly being used. So that later, I hope that the viewers can take this as part of knowledge that maybe you can utilize this method for the slope stability analysis. So let me a little bit explain about the Gabion walls, why we have this focuses this study on the Gabion walls, because number one, where one of the purpose is to stabilize slopes and to prevent the erosion, and also to reduce the landslide, whether in loose or unstable soil, so that it can protect the infrastructures, especially in urban area, and also in the to prevent any erosion, especially for the stream bank. So what goods of this Gabion wall, by having this function of wire mesh cage filled with rocks that allow water pass through, reducing uh, the hydrostatic pressure and also improve the slope stability. And we know that Gabion wall, normally we can look into, maybe if you're familiar with the Gabion wall, you can look most of the Gabion wall normally constructed in the riverbank, stream, so that it will be, since we know the function of the Gabion wall is to allow the water pass through and also reduce the hydrostatic pressure. That's why we can look many of Gabion wall constructed in the area of the riverbank or stream bank. Some of the Gabion wall can be seen into the area of the road embankment too. Okay, for the construction, it built as a gravity and reinforced and vegetated walls using local stone or recycled material. When also we have the lifespan extended with the galvanized PVC coated mesh. And there are numbers of series of the specification for the wire mesh itself. So but I'm not going to explain further about the difference, but what can we use this galvanized or hot coated and so on. But we are focusing the stability of this Gabion wall with different fill blocks material. Okay. So one another thing is the important part is about the cost effective, low maintenance, and also the low uh, flexible and also environmental friendly. By having this Gabion wall, it can support biodiversity, and we can use it into in the infrastructures and also protection, widely used in the infrastructure protection and also the environmental rehabilitation. And we can be used as the also can be used at having the high aesthetic areas. And some of the Gabion wall is used for decoration or aesthetic purpose. So in this case, what we do is for our study is we evaluate the factor of safety. We assess the saturation condition, assess the effect of material type, and we use the Morgenstern-Price method. This same like I mentioned earlier in the objectives, this is what we do. We focuses on these four work or four processes. Okay, by having this, we know that behind the Gabion wall, you must have this, we call it as backfill. So for the backfill, for the uh, bottom material, we are using the soil properties of the soil that having unit weight 15 kilonewton, cohesion 4 kilonewton, and friction angle 12 degrees. And we design, we evaluate the condition, the Gabion wall configuration, which is we're having a 2 tiers, a 1 tier, 2 tiers, and 3 tiers. Okay. Uh, these tiers meaning that the stack of these Gabion. Okay, in one case, for example, you have, we put another case on it, we call it one case, we call it tier 1. We put a second case, we call it as 2 tiers. Another case is 3 tiers. But we can play around with the configuration. Maybe 2 tiers with the 2 cage and the 1 on the top. Or maybe 3 cages, 2 tiers, another 2 on the top, and then another 1 to make it 3 tiers. So this is where the wall Gabion wall configuration that we are and focus on. And then we also do the understanding the condition, whether the Gabion wall is it stable under unsaturated, where the water table below the ground, partially saturated, where the water is maybe half or quarter of this Gabion wall height, and fully saturated where the water table is high. So for the material, fill material, we are using basalt, granite, limestone, and sandstone with the unit weight, cohesion, and friction angle here as listed in this slide. So we try to evaluate which types of rock can provide more stable, more efficient, and more effective for the Gabion wall stability. Okay, this is a result summary based on the three types or four types of rocks where we have basalt, granite, limestone, and sandstone. The average factor of safety for basalt under fully saturated is 1.33 to 4.9. Unsaturated is quite higher, 1.66 to 417. But partial saturation is quite less, 0.85 to 417. And similar with the fully saturated, this is based on the condition uh, or configuration of the wall. So it shows that the average FOS from 0.8 into 4. So for the tier and dimension impact, for the basalt, we have the highest stability wide base and low tears best. And for the unsaturated, the stability decreases with more tears and narrow width. For the partial saturation most detrimental, but what the key insight that we found for the basalt field material, the strongest, the assessed material low water absorption. Okay, we know that basalt is part of the igneous rock. The strength of the basalt itself is more higher than granite. With the material, the composition basalt itself, we call it as ferromagnesium, that high content of ferrum and also high content of iron, that can strengthen, increase the strength of the basalt, the rock itself, and also provide the more stable for the Gabion wall. For the granite, we have similar pattern to basalt, but they're slightly weaker. Like I mentioned earlier, basalt is the most densest one of the most densest rock as compared to granite. Durable but more weathering sensitive. Yeah. We know that when the granites come to weathering process, it will weaken the strength and can, through the mechanism, through the weathering process, it can lower the stability. Okay. Limestone, moderate stability with variance. Of course, limestone having a porous rocks, the strength can be lost under partial saturation. While the sandstone lower stability, many filled with narrow multi-tiers, but good things about the sandstone is it has high porosity, low strength, avoid without remediation. So, but then we need to know that since most of this material, most of the gabion walls we put into what we say into the mostly for the riverbank stabilization. So sandstone might be not working at all because it can erode the surface of the erosion and might cause the slope is unstable. Okay, this is the effect of material critical values, where this is the critical value that set the condition of the gabion walls. Okay, please bear in mind that these critical values basically focuses on where the factor of safety is below than 1 under regardless any condition. For example, maybe the tears, maybe the saturation condition. So what we want to focus is what are the most critical values that we can look into, that having the FOS have lower than what we say lower than 1. So among from this, we can look into it that basalt can be chosen as the gabion material is superior critical performance. Granite provides the acceptable performance with the appropriate design margin, while limestone may be acceptable with the enhanced drainage and monitoring. However, sandstone should be avoided unless extensive remedial work or measures are implemented. Okay, this is one of the effect of the material basalt, especially under the critical condition. Reason for performance, very high composite strength. This critical was evaluated under tier 3 dimension, which is 1 plus 1 and plus 1 under partial saturation. And the effect of material limestone, if you look into the tier 3 dimension, 2 plus 3 under partial saturation, where the condition of this, the factor of safety of this gabion was 0.857. And for this tier 3 dimension under granite condition, using granite fill material is 0.854. And for the sandstone effects, at the tier 3 dimension, 0.717. The factor of safety shows that this condition was critical under 3-tier dimension under partial saturation. So when we look into the partial effect saturation, unsaturated Moderate FOS was found 1.5 to 1.53. Partial saturation, we're having the lowest FOS with 1.38 into 1.445. This is because of the positive water pore pressures developed during the wetting and reducing effective stress. By having full saturation, we found that the FOS is quite higher, which is one of the highest, 1.8 to 1.861, because the hydraulic static pressure provides a uniform lateral confinement and water flow through permeable gabion and enhance the particle interlocking the effective stress. So that's why we know that the application of gabion wall is good where to protect the river bank or stream bank. This is the effect of the tiers and dimension. If you look into the fact based on the graph here, factor of safety versus number of gabion wall by tiers. So this shows that the highest stability FOS value for the tier 1 is 1.1 to 5, and the tier 2, the values between 1.8 to 2.4, and the tier 3 0.7 to 1.6. And we look into by having number of tiers, sometimes it can reduce the stability of the FOS because of the center of the gravity itself. As the V stack increase, the stability might be overturning, maybe slide. So allow deeper slip surface, and they sometimes increase the base with strongly improved stability if we have a good base enough as also the fin material. By lowering the center of gravity, increase the frictional resistance and further shortening the slip path. The data confirm that FOF rises almost exponentially with width, actually, and on the thicker material. So as far as the conclusion for this study, we found that the best stability find in the white base, as single tiers, and also with the good material and also good drainage. However, by narrow down the wall configuration and also by having multi-tier walls, it can reduce the factor of safety. But we know under the full saturation could potentially improve the safety, factor of safety with more than 1.85 because of the reducing hydrostatic pressure. And also we conclude that material selection strongly influence the stability of the gabion wall, and also the geometry and interior configuration are critical design factors. And also we can help by optimize the gabion wall design in order to stabilize the slope. I hope you can get some knowledge from this session here, hoping that to see you again in the next session. Okay, thank you so much.